Okay, now reaching the analog input output pins programming. Okay, first analog input. Okay, as we know, analog input pins are perfect for reading sensor values. Okay, reading sensor, which don't just have two status, but provide a range of values. Okay, for example, we have here sensor. The values from this sensor range between 0 volt and 5 volt. 0 volt, 5 volt. The result is varying between these two values. Okay, due to ADC, analog to digital conversion process, and with a 10-bit resolution, as we explained previously, the 0 volt signal is translated to a digital value which is 0, and the 0.5 volt and the 5 volt signal is translated to a digital value which is 1023. And the command that is responsible for this reading is analog read the pin number, of course, from the analog pins. Okay, for example, we are using analog pin A0. So here you define A0. This value should be stored where we can access it and display it. For that, we will define a variable int sensor value. This is the variable that will store the results, the values. Int sensor value equal what? Equal analog the result. Read the pin we are using. Semicolon. Here's a practical example to explain the analog read function. Here is the potentiometer example. First of all, we define a variable, constant integer variable, and assigning it to the used pin, which is A0, to read from it the values of the potentiometer. Okay, first of all, const represent constant variable, cannot be changed, not can't change. Okay, during the execution of the code. Int represent integer, pin used, it is the name of the variable, equal A0, the used pin. Okay, for the setup function, as you notice, there is no pin mode function since the analog pins are by default input. So pin mode function, it's usually used for digital pins. Okay, serial.begin 9600. This is used for the initialization of the serial communication, allowing the Arduino to communicate with the serial monitor to display the values that we read from potentiometer. Okay, for the void loop function, first of all, we used the function analogRead to read the values from potentiometer. Okay, analogRead pin used. This represent A0, the analog pin, and analogRead to read the values from the potentiometer, and they range between 0 and 1023. Okay, these values are stored in a variable. We named it value. Int value. We define a variable integer value that stores these values to be displayed on the serial monitor. Now serial.println what? The value. This function is responsible to display the values on the serial monitor to be shown by the user. And finally, delay 500 milliseconds. This ensures that the readings are not sent too quickly. there is a delay or a time pause between each value, which is 500 milliseconds. Okay, for the analog output, we can simulate an analog output, simulate an analog output on digital pins using what? Using PWM, pulse width modulation. Check the hardware part 2 video to know more about PWM, where we explained in details. Okay, the most popular example for this analog output signal is dimming an LED. Okay, the command that is responsible for this simulation is analogWrite the digital pin used, not any digital pin, only the digital pin that has this symbol right beside it. Okay, analogWrite digital pin number used, comma, the value to send, semicolon. Okay, regarding the value that it can send, this command, it varies between 0 and 255, since the PWM in Arduino Uno works on 8-bit resolution. That means 2 to the power 8 equals 256 minus 1 equal 255. The maximum value it can simulate for a 5-volt signal is 255. Now we will take a practical example to understand PWM or analogWrite function. For that, we will take the dimming light example, dimming LED example. So first of all, we start by declaring a variable LED pin to save or to store the number of pin we are using. For sure, not any pin, only digital pins that support PWM, support WM, to know which pins they have this symbol beside them. Okay, now for the void setup, we want to define the pin we are using, pin mode, the pin we are using, let pin, okay, as an output pin, so we can send signals to the external device used, which is LED in this example. Okay, send signal to LED. Okay, now for the void loop function, we start by writing the analogWrite function. Okay, analogWrite, we want to send a PWM signal to what? For the pin we are using, which is LED pin that represent 9. And the value we want to send it, or the PWM signal we want to send it, is 85. The value of it is 85. Okay, where this function, it takes values, or it can send values from 0 to 255. So as we send a value of 85 to the LED, so we are sending a signal that represent a 33% of brightness of the LED. Okay, now a delay of 2 seconds, it holds the brightness 2 seconds before moving on to the next state. Okay, now moving to the next state, we define analogRite LED pin 170. So 170 represent a signal of 66% of the brightness of the LED. And, as well, we write a delay function to hold this state for 2 seconds. Finally, an analogRite function that send a maximum signal for LED, which is 255, which represent the 5-volt signal, and for that it is 100% of the brightness. Also delay to hold this state for 2 seconds, then the loop function will repeat itself. So as a conclusion, this program will cause the LED connected to pin 9 to cycle through 3 different brightness levels: a low brightness level, a medium brightness level, and a full brightness level. Each brightness level is held for 2 seconds before transitioning to the next state.